That's the way to start. There you go. Sorry. Thank you. All right, folks, we'll start now. Yeah. So, good afternoon, everyone. There are some good news, really. This only may take half an hour, so it's not 1 hour. But where's the guy? Um, okay, he's not working. It's about, she said.
You guys hear us in the back? Just show
Yeah.
the speaker or just us yelling.
And I'm sick on top of that. Yes. It's not working. Okay. Again, my name is Steven Singam. I do research for Digital Network. We focus mostly on bots and API endpoints, and it's Christian who does the engineering work for us. So our topic today is mostly about chatbots and how do you unmask it, and what are the risks we see, and what are the high-level ideas that you can mitigate those. Thank you. So what are chatbots really? I mean, obviously everyone knows what chatbot is, but it's becoming incredibly a large volume market. So Gartner assumes that by 2020 it's going to be a $97 billion market. So it's rather large. And from the application point of view, we believe that down the road, there will not be anything such thing called application, be all bots talking to each other. Maybe too future thinking, but let's think about that. The capacity of the bots these days is quite large. So obviously, bots do exist for a long time. Chatbots, I meant. MX used to use this in 1995, but it's a kind of dummy bots. It's not like intelligence behind it, really. Can I verify you, blah, blah, blah? Then it says yes. But nowadays, the bots these days are quite intelligent. There's a lot of supervised, unsupervised learning behind this. So it's becoming more potent in terms of business point of view. So what are the key trends? Obviously, messaging as an OS is becoming a big deal. API introduction, conversational interface as an API, and Facebook does 600 billion chatbots per day. I find it hard to believe, but that's the data. 600 billion a day, right? And people are more and more reluctant to download mobile apps. That's what I meant to say earlier, like the future of web will be mostly bots interrelated or interreactive, really. And then obviously, from the business point of view, is customer intelligence. The four main stacks, really. Obviously, the messengers, right? It's typical plain messengers like you see in WhatsApp. It's a platform just to send the messages, really. And then second thing is obviously the parser. Parser is a little complicated. It's kind of a gateway, really, understanding where it's going, what supervision is going to go, and then what message is going there, what kind of security control are in place, how are they custodian, in essence, right? So obviously the bots, we see a lot of Siris and Alexas, the Amazons and that. But the other biggest trend we see is the AI as a service. I think that's becoming a really a major driver for chatbots, really, because there's a lot of AI chatbots library people can download as a service. Deep learning, obviously, how to make the chatbots more intelligent, more interactive. As I said, end of the day, the essence of chatbot has to be very human. Simple as that, right? The closer you get, it's better. And the machine learning. And the services, obviously, it's kind of related to the gateway too, in a way, but it's more of a service bus, really, right? For back office, front office, versioning, archiving, to which destinations. The last thing is the state management, right? How it is managed. I've seen a lot of Kafkas involved these days for state management. Redis is involved, and protocol buffers are involved. So it's becoming more and more complicated. So what this has to do with API, obviously, right? I mean, the single-page view in APIs these days, I think people are going straight to the API. So where we got involved from this deal is that we usually protect malicious bots. But what we're seeing more and more people, hackers actually going straight to the API endpoints, bypassing the web. So that's why we got interested. So API obviously is the glue, right? It negates the CSS interface. In many cases, the even the GIF files in some cases, actually, and then able to talk to many platforms. For example, from Slack all the way getting data from Salesforce data to Slack to back office Mongo, right? So end of the day, we are hoping it has monitoring, testing, and security. That's where the question comes in, is it really security? That's why we're going to show later, how we can actually bypass security. And this is the actual KLM, does chatbots for managing, I'm sick today, so bookings and stuff like that, okay? But let me give you another example. Before this, I used to run a bank, CISO as a bank in a southern hemisphere, and most of the bank transfers, unfortunately or fortunately, is done by voice, believe it or not. Really, it's like, who are you, blah, blah, blah. Then someone happened to infiltrate into a South African passport office and able to get the data all through voice verification, chatbot verification, able to transfer $2 million overnight from Australia to South Africa, right? The money never to be traced again, right? There's two things here, right? Because the chatbot facilitated this kind of transaction. Second thing is that the chatbot architecture, the technology, was so immature to find forensic levels. So it's two things. It's a conundrum there, all right? So this is a typical scenario how actually a chatbot API works. And when it comes to the API gateway network, I want to say that one of the areas where people don't see properly in terms of API management is the API ecosystem, right? It's a real ecosystem from marketplace, portal, to the services, to the versioning and archiving. People do not see that very well. In fact, we talked to New York Times yesterday or the day before, the same issue we are seeing that there's a lot of silo within departments about how APIs are managed. Imagine on a chatbot level, right? So that being said, let's see how Christian hacks this.
Sure. How's it going, guys? My name's Christian Dehoyos, and I will be praying to the demo gods in front of all of you today.
At least it's honest.
Yeah. All right. Okay, cool. So, like Stephen just said, the goal today is really to hack a chatbot API, but really what is it? It's an API. So if you're going to be looking at all the same vulnerabilities that would go along in an API, that if you've done research through OWASP or just plugging around on the internet, they're going to be the same for a chatbot API that you would find from just a normal API. So we go into the details of like common attack styles and all that kind of stuff, but I'm just going to fall on my face in front of you guys real quick. So the first one, SQL injection. So last night we took the liberty of trying to find a few apps that would allow us to do some of this kind of legal hacking to break in. Weren't successful, so we decided at the last minute to build our own chatbot. So what you're seeing here is my chatbot. It talks to me at night. So you could do all the standard things that you do with a chatbot. Like, hi, how are you? Are we today? Where are we today? Cool. What's the time? Cool. So it's not completely sentient, but it's reasonably smart. Cool takeaway here when you're looking at chatbots, even though this one is incredibly dumb, is that most chatbots aren't that much smarter. A lot of them are API mashups with a language parser, like Stephen was saying. It's going to be taking that language and then breaking it apart, maybe sending it to another API service like, API.ai, or maybe a different place to parse it out. But there might be another API service that's working with it, maybe at a service level, that you can exploit. So In this case, we have another background API or a bunch of different services that are running that are vulnerable. In this instance, it's going to be a SQL injection. So, do all the normal kind of things that you'd be doing if you're a pen tester. So you fire up Kali Linux, run an Nmap scan. One of my favorite tools that I've been looking at that was demoed at AppSec recently a couple months ago is this thing called Fuzzy API. So it's very similar to just like normal like OWASP Zap, where it'll catch that traffic like a proxy and then kind of break it down to show you what's in there. But it'll take it to a next step and say, okay, of all the normal attacks that we see on APIs, what are you going to look at? So this is kind of, I've used a few of those different tools. I could show you later about what goes onto it, but let's actually just get into it. So from some prodding, I was able to find that in this chatbot, if I was to just do a simple user search, I know this is incredibly straightforward. It's like no one's going to just kind of leave user/2 open, but in a lot of different circumstances for open APIs, it's a different object that they'll leave open. So if we were to leave that open and then kind of keep doing some prodding, you want to find out how many columns that are going to be in this database table. Find out that it's just going to be first name and last name, which is critical. So then you can start really doing some add-on arguments to it to see really kind of what are the limits to this database, what's going to be, what else can you pass on along it. So for here we're saying, okay, for of those 2 columns, order it by 2. We want to see exactly how much data that we can have coming back out within the parameters that the database sets. So if we're going to keep moving along, I know this is incredibly fascinating to squint at these texts, but this is where it gets interesting. So I know right here it just says, Gordon and Brown, pulling it straight out of the database, and then first name, last name. But what happens if you were to plug something a little bit more interesting, like instead of the last name? Oh, yeah. Okay. So let's do this. So instead of just sending, database 1 and 2, I'm going to pass along the version. And there's a ton of different arguments that I'm sure for those of you that have actually played along with this that you can actually pass. So this is just simple. What's the version number? I want to run this in exploit database, see where the vulnerabilities for this version are. Super straightforward stuff. But maybe if you want to do something a little bit more advanced, you want to find out who's the user. Pull up localhost. So, there was a lot of different other kind of arguments that I was trying to look at last night. It was at 3 a.m. I was super tired. We flew here from San Francisco. So find me after this. Love to show you a lot of different resources that I'm going in for this. But let's just say if we're super bored and we just want to get all the information and eventually just get to the secret. If you look in here, if I'm going to pass, I can't really zoom in, but if you're basically going to add on a union select statement, and normally where you would pass that first user where you have user 1 and then 2, you're going to pass along table name from information schema. So you're going to just pretty much wherever that normal number 2 would be coming out earlier, you're going to basically just start asking the database, what else can I pull out? So this is the result. Start getting all the different columns from all the different databases. What I'm interested in and what most people are interested in, if you're going to be exploiting a chatbot API or really any rudimentary application, is the users table. Password, username. Just find user. There's user privileges right here. Go a little bit farther down, users table. Boom. So last thing, we want to see all the different columns that are within the users table. Pass that along. And see, we'll be seeing here that from a first name, we'll be pulling out, from the first name column, last name, Brown. But what's interesting, if you look at that last piece, is secret. Again, not totally real world. It's not like this is going to happen at a bank. But in a lot of different applications, you'll be surprised at how misconfigured or what kind of options are out there if you just simply kind of start poking and prodding. So last one, if I just wanted to get, given that database was only giving out 2 columns of first name and last name, and that second is what I was trying to get, either local, root, or whatever the version was. If I wanted to get first name and have a correlating pass, that's simple. And then you could toggle in between to have first name or last name and any other correlating details from it. So hopefully that was straightforward. But let's get into that second live presentation. Right? Wrong. I couldn't get it working. Last night while we were doing it, at 3 a.m., 4 a.m., just stuff starts to fall off. You guys have a Waffle House open out here. We had different things we had different plans. But the second one is extremely important because I know Stephen was talking about it earlier. XML parsers are kind of like that last or first gateway in mechanisms to decrypt that or to take apart that data and have the application interact with it. So a very common attack is a DDoS style attack called an XML bomb, or they call it a billion laughs, because if you look at this code right here, I'm not going to explain it. I'm not going to explain it for those of you who took a Saturday out to look at code, what the code does. But basically, it will turn that line of code into 3 gigabytes of XML code recursively. So what we were able to get was the logs that said that, okay, in the middle of the night when I'm doing this test last night in the hotel lobby, we were able to see a CPU spike on different variations of that. That's the vanilla code. You can change it around, pass it along different things, but we were able to get it, and it's very easy to do. Later on in the talk, I'll show you where you can actually test this out like a firing range. So, kind of wrapping it all up. You guys saw the hacks. You guys saw kind of how chatbots work right now and why it's economically really important, why it's fun, why you can hack it, and why that can make you money. But why an API over a regular application? Mostly because APIs are a lot harder to protect. Not all APIs are, they're kind of a unique snowflake. There's different authentication mechanisms, there's different standards, and it's kind of a moving target. If you look into OWASP right now, there's teams that are trying to make stuff more standardized, like releasing a top 10 for vulnerabilities in APIs, but it's not there yet. So there's tons of opportunity. Great because there's manuals in some of these well-documented APIs. Bad because some of them aren't documented, like the ones that are going to have vulnerabilities aren't going to be documented. It's not obvious like a UI. The attack vector is larger, but you can't see it. It's not like going to a web application just clicking around on things. You're going to have to prod, in a terminal, which isn't always as fun as like what I did with my browser. So my best recommendation, and then again, just letting you guys know, if you guys are at B-Sides, I'm just letting you know that I would be open to any sort of criticism or comments on this. But for my API, reconnaissance, there's passive and active. So for passive, we're going to be looking at, if there is different API documentation, is there any mashups that are already leveraging a REST or SOAP API in GitHub, searching Google, different ways to be able to find out what's out there and how the path file structure runs is going to be extremely important. Another one is man-in-the-middle proxies. So Zap, this API, Fuzzy, there's tons of them, Burp Suite, being actually able to catch that traffic and kind of roll it back out and see exactly what can be done with it. I know at another B-Sides, a penetration tester was able to decrypt in most dating applications that they passed along the most recent geolocation in their REST calls. So if you had a man-in-the-middle attack and you were on one of these niche dating apps, you can catch that traffic and find who the person that you were in love with, where they were, and stalk the living bejesus out of them. I don't recommend it, but the thing about being able to capture that traffic, if it's misconfigured or if the headers aren't really locked down, you could do a ton of weird shit. So another thing, rate limits. I have a friend that was able to drain out in a pretty sizable database of public information because they didn't rate limit. They were just able to just keep it running, as well as header configurations. Got to just kind of run it out. So I'm going to really briefly just go through popular attack styles, and I would like to close it out with dogs, mostly corgis. So we're going to have them fighting on the beach. But these are kind of the who's who of common attacks for hitting a REST API. So any of these things that if you Google and how it would relate, you can get a lot more information, and I'd be happy to provide it. But you're going to be looking at invalid input attacks as well as malicious input attacks, ways that you're interacting with the API, as well as different types of either cross-site forgery, or there's different kind of permutations of that as well. Or more importantly, the bottom one, misconfigurations and just bad handling, or just the way that it was written is not up to date, or it hasn't gotten patched, or there's clues in there. So, injection attacks. Main takeaway for this is that it doesn't always have to be injecting into the API for making a call. Like for in this instance, I have the Swagger exploit, which it has that CVE number if you want to read into it. Swagger is the main tool used for most applications that want to quickly create a REST API. So if you already have a database and you're like, hey, I want to have a REST API, you'll probably use them or someone else. They have an open exploit. You can inject code, directly go outside of the API, go up or above it, pop it, and get to run your own code and kind of do whatever you want. So there's injection attacks, cross-site scripting. I'm sure you guys heard of it. There's both reflective and persistent. So there's different ways in which you can use cross-site scripting to interact with that. Cross-site request forgery. I was going to have a long story about how that would work, but the high level is getting the web browser to be tricked into doing something that the user wasn't intending. So in this scenario, it's the user goes to log into their bank, sends back the cookie, then they get prompted to go onto some sort of funny website from an email that says, hey, this is a coupon to a place where you want to buy some fun stuff, and it's not really that. It's just some website that the hacker created to steal that information. They're still leaving that session open from the bank. They go in, take over, send over some sort of kind of action that because that session is still open, they're able to take advantage of it. Again, with banks, extremely rudimentary. That's not the case. This isn't Swordfish. But for other websites, it's totally possible. I know when I was doing research kind of more on these types of attacks, these are fewer and farther in between, but they usually cause a lot more damage and are harder to detect. So super fun stuff. And then last, again, kind of more of a low-hanging fruit for websites that aren't as well configured or locking stuff down, but insecure direct object reference. So occurs when the application provides direct access to objects based on user-supplied input. So I was going to have a big picture of like, OWASP, watch out, this is a total thing. But this is more straightforward. Being able to go to the URL if it's not completely locked down and play around with what does menu item 13 mean, or 14, or image 0012 or 13, or like in my application, what does user 3 do? If it's usually with more complex applications that have to work with multiple services, multiple teams, that developer or development team, for maybe ease of use or just getting a deadline done, left the door open in a very obvious way. So lastly, last dog picture. There's a lot of documents out there for when you're doing this sort of testing on REST APIs or just APIs in general. And a lot of them just kind of come down to questions. So a lot of the main ones that I like to close out on are the session tokens reused? Are the timeouts set up correctly? Just kind of all the basic stuff. But a lot of these questions are kind of worth asking whether you're on the blue team and you're defending or you're writing this code, or if you're on the red team and you're going through a methodology of how will I get into this application or web service. So useful resources still needs links. So when I send this out later, there will be more links, but kind of reference them. The fuzzy API is great. I got to play around with it a little bit yesterday. OWASP Zap is a fantastic application for catching traffic. It's open source and has a lot of years of development under it, so it's a very solid program. Anything with the API security project from OWASP, they're going to have a lot of documentation over what's out there right now, as well as any new updates. And then the last thing, so this damn vulnerable web services application, there's a lot of kind of capture the flag applications out there for how to root an application, how to root a Ruby application, a Python application, a website, or whatever. But this is a great application that has a lot of service level vulnerabilities. So if you're testing REST SQL injection, like I did to make a mashup, or XML bombs, or a bunch of other fun stuff. So I would definitely recommend taking a look at that if you're going to be doing testing, or if you just want to play around. But told you I'd keep it pretty short and sweet, so hopefully everyone gets out early. Any questions? Nope. All right, cool. Thanks, guys.